9.2, we're talking about series. Let me look at the title for this one. I'm gonna go straight to the problems. Okay, I'm not gonna go to the PowerPoint for this one. Series and convergence. I know right now we're talking about the limit, but now we're gonna talk about the sum of them to see the sum converges or not. First of all, we're talking about a partial sum. What is a partial sum? So here where it says Sn and not S1, that just means we're gonna plug in a 1. So I'm gonna put 5 over 2 to the 1 minus 1. 2 to the 1 minus 1, that is 0. So that's going to be 2 to the 0 is 1. It's just going to be 5. You're going to, the sum, you're going to here, you're going to use the previous one plus, and I'm going to add a 2. I'm going to put 5. 2 to the 2 minus 1. And you're going to add it. This one, you're going to put the first one, the second one, plus the third one. For is a 4. You're going to have the first one, the second one, the third one, plus the fourth one. Next one, you're going to have the first, the second, the third, the fourth, plus the fifth one. Okay? You're going to put in the calculator, you're going to round to decimal places, and that's how you do that one. Okay? This is called partial sums. I'm only going to 1, 2, 3, 4, 5 terms. Okay? Well, what happens if I want to add all the way to n? I want to add all of them. Okay? Well, today we're going to cover 2 tests. Okay? First one is going to be a geometric series. And so for a geometric series, for the sum, this is called a sum. For a sum of a geometric series, for a sum of a geometric series to converge, the r, which is this right here, needs to be between 0 and 1. If r is greater than 1 or equal to 1, it's going to be divergent. It's not going to diverge. The sum is not going to be divergent. The sum, convergence means that we can find the sum. Okay? Even if it's infinity, there's a sum. So this is a formula we're going to be doing if r is between 0 and 1. Okay? So let's get started. Again, these first examples are for geometric sequence. So here, my r, let's look at r first, is 5 over 3. Well, this is greater or equal to 1. It is not between 0 or 1. What does that mean? That this is going to be a divergent sequence. The sum does not have a final sum. It's going to keep adding, it's going to keep growing. It doesn't converge. This next one, okay, next one. What is r? R is 0.4. Well, the r, and it's the absolute value of r, but in this case, these two cases r is positive. So r is between, this one's not equal to. This one's just less than. This one's greater than 0. Oh, r cannot be 0 because then we don't have an r. Between 0 and 1. So that means that we have a convergent. Okay, we have a convergent. Okay, for those first or the next questions like this one, all you need to tell is if the r is greater than 1 or if it's between 0 and 1. Okay, and they're asking you to find r. The next question though, it says find the sum of the convergent series. They're telling you it's a convergent series. And you have a r to the n, so we have a geometric. They don't tell you it's a geometric series, but it's a geometric series because it's in the format of a r to the n. Okay, so in this format, So let me write it. A r to the n, and it's going to be a, that looks like a 9. Sorry, it's an a. 1 minus r. That will be what it converged to. Okay? That's what it's going to converge to. So in this case, a is 6. 1 minus r. My r is 2/3. And all we need to do is simplify it. Okay? And I'll let you simplify it so that I can go over the rest of them. Okay? Simplify that. Okay? You need to simplify that, and that will be the convert. Now, let's simplify it. It will be common denominator 3/3, 2/3, which will be 6. 3 minus 2 is 1. The denominator can be 6/1, and we copy, change, flip. We see that's over 1. 6 times 3, 15. Okay? Next one. That was a geometric series. Now is the nth term test. Okay, the last test, last term. If the sum from 1 to infinity of a of n converges, then the limit is 0. So in the same manner, if the limit is not equal to 0, then the sum diverges. Okay. This term here says verify using the nth term test. So in this case, it's verifying that it diverges. Okay, how do I know it diverges? Well, here I have it up here. What is the limit as n approaches infinity of n cubed plus 4 n plus n squared? And we covered this in 9.1. Okay, I just did it right now with you guys, or in the other video. Remember that I don't care about this ones right here. I care about the highest exponent. If my highest exponent is in 3/3, that simplifies. The coefficients are 1, so that simplifies to 1. The limit as n approaches infinity of a of n is 1. It is not 0. That means that this will be a divergent. Okay? Because the limit is not 0. Not 0. Find the sum of a convergent series. In this case, they're telling me is a convergent series, okay? They're telling me is a convergent series. Okay, so to simplify this one, or to find the sum of convergence, we gotta do partial fractions. Okay, we did partial fractions in another chapter. I can't remember which one, but we did partial fractions before. So I'm not gonna go step by step, but here it is what I did, okay? A over n plus b over n plus 2. Remember that this one's missing the n plus 2, this one's missing the n. And then now I only care about the numerator, okay? So then I distribute the a, I have a n plus 2a plus bn. Which one has the n? The an plus bn. That means a plus b. And if I look at the original problem, there's no n. So that is 0. Okay, so that's why I put a plus b equals 0. And then 2a equals 8 because there's a number 8 on top of the original function or the original a of n. So then here I solve for a, divide by 2 and I get 4, plug it in into this one and I get the b is negative 4. So then I replace now with my partial fractions the original with 4 over n minus 4 over n plus 2. They both have a 4 in the numerator, so I can take it out. Okay, so now let's see what happens with the sum as we approach n. Okay, remember there's a 4 right there. There's a 4 right there at the outside. I just want you guys to see what happens if I plug in 1. Okay, let's plug in 1. So it will be 1 over 1, which is just 1, minus 1 over, so here will be 1 plus 2 will be 3. That's my first term. Second term, I'm going to plug in a 2. I'm going to plug in a 2. I'm going to have 1/2 minus 2 plus 2 will be 4, so 1/4. Let's just plug in a third one so that you guys see what's going to happen. 1 over 3 minus 3 plus 2 is 5, 1 over 5. And this is going to keep on going forever and ever. Remember that the last term will be n, so the one before that will be n minus 1. I'm going to plug in n minus 1 to this one, see what happens. I'm going to have 1 over n minus 1 minus n minus 1 plus 2 is going to turn into 1 over n plus 1. Plus, now I'm going to plug in an n. So this is going to be 1 over n minus 1 over n plus 2. Okay? So that's going to be all of it. Okay, if I continue forever and ever all the way to n, and remember, n is going to be infinity. Okay, so what happens? Well, look at this. Negative 1 over 3. Positive 1 over 3. Cancel. Okay, and things are gonna start, like, they're gonna be canceling out. Okay, so then that means that this one right here is going to cancel with another one over here. This one's going to be canceling with another one over here. Okay, so the only ones that are not canceling is this first ones right here, the 1 and the 1/2. So then I have the 4, I have the 1, I have the 1/2. And then if I continue, well, from right here, you see how this 1/3 is going to cancel? Well, then a positive 1/4 is going to cancel. A positive 1/5 is going to cancel. So this is going to cancel. This is going to cancel. The last two right here, if I follow the pattern, are not going to cancel. So I have minus 1 over n plus 1 minus 1 over n plus 2. Okay, so now I want to find the limit. Well, let me write it over here. I want to find the limit as n approaches infinity. Well, if I put infinity here, this is going to go to 0. This is going to go to 0. Okay, so it's going to be 1 plus 1. Let me see. Plus 1/2. And then we have the 4 at the outside. Don't forget the 4 on the outside. I was about to forget. I'm like, what? Sorry, don't forget the 4 on the outside. So then here, we're going to distribute that and get 4. 4 divided by 2 is 2. And so my final sum will be 6. Okay? I know it's a lot of work. That's why I only do a few of this one so that it is not too complicated.